Okay, this is the Where's the Heat lab from Where's the Beef back in the early 80s at Wendy's commercial. I had to do a lesson one time and I threw this together in my mind. And if you're in my workshop here, and on the back of this there would be a graph paper. So hopefully you've got a packet with a graph paper, but you'll need one. It could be on the back of this or something. This, you can get it from a PDF from me if you need to, or retype your own or something. But basically, you're going to get a beaker of ice and a beaker of rock salt or ice melter or something. And you're going to have these sitting in the room. This is going to be at room temperature at 25. This is going to be at 0. So I'm going to navigate off of this page, but I'm going to read off of it at times here. So the idea is, this is what makes, and I want to end with this, I can, the ice melt in the ice cream machine. And I guess this is how I have the lab put together. And I start at -15 and go up by ones, zeros up a ways, and then every minute you're measuring the temperature. And this takes about 20 minutes. Okay, so you got your rock salt and your thermometer in here, and it's room temperature at, I don't know, let's say 20 degrees Celsius. And the ice, you bring it out of the freezer, and the kids are coming in, and you get them all settled, get them started, get the temperature measured, and the temperature's probably still rising for a while, a couple minutes there. It gives you some directions, and it's for the first 4 or 5 minutes. What happened to the temperature? It rose to 0, and then it stays at 0. And you let it stay for 0 for a while. Now, at this point, we've already done the curve for water. The heating curve for water. They know it's going to stay at 0 until the ice is melted. But what process begins to occur with the ice? It begins to melt. See, is heat going into or coming out of the beaker? It's going in from the room. If you can let it sit, what's going to happen after a few more minutes? It's going to stay at 0. And you keep talking about that. What do you expect to occur? Now, sometimes students will be, well, the salt is at 20 and the ice is at 0, so maybe mix them together and it'll go to 10. And then other kids might think, well, it's going to be somewhere in between, but maybe not 10. And then other kids may have realized that, oh, the temperature is going to go down. Now, here's the thing that makes this lab different. So what? Aha. If you go down to the bottom of the paper, and you ask the textbooks, all of them, you ask 50 science teachers, almost all of them are going to tell you, because salt lowers the freezing point of water. Well, what you just explained was, if I put salt water in the freezer, why it won't freeze at 0 and has to get colder. What you didn't explain is why this temperature dropped. And you do this, you keep it mixed, you can get that down to -14, 15 degrees Celsius. How did that temperature go down? When you say salt lowers the freezing point of water, you didn't explain why the temperature got colder. Here's why. So that's what you get to in the gist of this lab. Well, let's look at the questions here. It says, if salt was added, what trend occurs in the graph? It goes down. They see that. That's very clear. Gee, why did the ice melt so quickly? So when you put that salt in there, it melts ice really fast. It really starts turning ice to water quickly. Well, what you did, here's the explanation. When you put salt on the ice, you forced it to melt. We don't even have to know how that mechanism works, but we put salt on ice, we forced it to melt. You put ice on a snowy road, you force it to melt, and it gets even colder. But ask the question, what causes ice to melt? Adding heat. but we didn't add any heat. So if we forced it to melt, but we didn't add heat, where did we get heat from to melt it? Ah, that's what happened. It took heat from the glass. It took heat from the ice cubes. It took heat from the water and the salt and the thermometer and anything it could find in there. And it gave up heat to melt ice, all from inside here. So if it gave up heat, you had to make molecules move slower to take some of their energy away. And that's what the temperature dropped. So the explanation is you forced it to melt without adding heat, so it had to take the heat from itself, and that's why the temperature went down. It wasn't because salt lowers the freezing point of water.